Hi everyone, welcome back to chemistry. In this video, we're just going to jump over to chapter 7 for one section from the chapter called 7.1 Equations for Chemical Reactions. We'll go over the rest of chapter 7 in future videos in different modules. But for this module, we're ending on 7.1 just as kind of a side note, just to kind of introduce you to the idea of chemical equations. So remember one of the previous videos, I talked about how this arrow here, separates what we have before the reaction, so different types of chemicals that we start with, and what we have after the reaction, or different types of chemicals or compounds we get out of the reaction. So it's separating before and after some kind of chemical reaction. And remember that I abbreviate reaction RXN sometimes, okay? So when we are writing our chemical equations, it's the same idea. That arrow is separating what we have before the reaction happens with what we have after the reaction takes place, okay? So, this is an example that you have in your book, and it's just to kind of show you the general setup of a chemical equation. So, on the left here, before the reaction, I have 2 wheels plus 1 bike frame. Okay, so that's before the reaction. And then after the reaction, I have 1 bike, a full bike, and it's made of those 2 wheels and that 1 bike frame. Okay, so those 2 things that I started with have combined to form one thing. And that's a specific type of reaction, and we'll talk about that in the future. There are a few different types of chemical reactions that are common. So they fall into different categories, but we're not going to name those now. But just so you can get a general idea, I have these 2 things on my left, which you could think of as before the reaction, but in chemistry we call these reactants because they're the things that are reacting. Okay, so whatever's on the left side, and it might not be 2 things, right? Or in this case, 3 things technically. It might be several things, it might be just one thing, okay? But whatever's on the left side of that arrow is called a reactant. And then on the right side of that arrow, we have what's called our products. In this case, it's a product. We only made one thing, right? But whatever you get on the right side out of your chemical reaction is what you're producing. We call it our product, what you're getting out of the reaction, what we're making, what we're producing. Okay, so I'm going to start referring to things on the left side of the arrow as reactants and things on the right as products. Okay, but you can still think of it as before the reaction and after the reaction. Okay, so let's see. So that's a basic kind of setup for a chemical equation. But the most important thing about chemical equations is that they need to be balanced. And what do I mean by when I say balanced? I mean that, remember in the last video we talked about how atoms can't be gained or lost in chemical reactions, right? So if we start with 4 hydrogen atoms and 2 oxygen atoms, on our reactant side, we need to end up with 4 hydrogen atoms and 2 oxygen atoms. Okay? We can't gain or lose those atoms. They're still there. There's still matter. We're conserving that matter, the law of conservation of matter, or similarly, the law of conservation of mass that we talked about, right? We start with 5 grams of our substance. We better end with a total mass of 5 grams. Even if that substance looks different, right? So our hydrogen and oxygen atoms might be bonded differently on this side than they were when we first started, but they're still all there. Those actual individual atoms are still there, okay? So how do we actually balance a chemical equation? So the first step in balancing a chemical equation is to make sure that you write the equation using the correct formulas for the reactants and products. So the formula is this. This is a formula, this is a formula, and this is a formula. And what do we mean by formula? So if you look at your ALS, not ALS, AL2S3, these numbers down here are your subscripts. And in a previous video, I mentioned that the number there under your atom is telling you how many of those atoms you have. And they're always shown to the right of the atom that they're talking about, okay? And so you might see on like Microsoft Word, you'll sometimes see it like written like this, I think, or X. Yeah, I'm pretty sure it's written like that. And that's just saying like, okay, here's my atom, and here is my subscript. Anyway, sorry, that was kind of a side note. So the number there tells you how many atoms of each type you have. So in this case, how many aluminum atoms do we have right here? 2. Yeah, and then how many sulfur? 3. So there's 2 aluminum atoms per every 3 sulfurs in this compound. And it's a compound, right? That's why it's written together like that. See how it's separated by that plus sign over here? It's written together here to show you that these are bonded together. And we'll talk about what chemical bonding is in the future. But you could think of them as, right now they're combined. So similar to CO2 or H2O, those are more compounds, right? So if we don't see a 1 here, we just assume, or any number there, we assume that there is 1 of that substance, 1 atom. Okay, so right here there's 1 atom of aluminum, and there's 1 atom of sulfur. You don't want to write out 1 here. It looks really funny. Like, so normally when we're balancing equations, there's some spots where writing 1 doesn't look that weird, but in this case it does look weird. So don't write it like that. Just put the 1, the atom symbol down, okay, or the element symbol, I should say. All right, so, and then what do these S's mean again? Yeah, that means it's solid, okay? That's the state. That's showing the state that element or compound is in, okay? So it could say, you could have an L there, and that would mean you had a liquid, or a G would mean you have a gas. We'll see other ones in the future. Okay, so that's step 1. We wrote the equation, using the correct formulas for the reactants and the products. All right, step 2, though, is to count how many atoms of each element are in the reactants and the products. Because remember, we need to have the same number of atoms in our reactants for each element as we have in our products. So what we put in, we need to get out, even if it looks a little different. We still have those aluminum atoms and those sulfur atoms present. Okay, so on our left side, let's color code this a little bit. On the left side, on the reactants side, we have 1 aluminum atom. And how did I know that? Yeah, because there's an imaginary 1 right there. Okay, so I have 1 aluminum atom, and how many sulfur atoms? Yeah, 1, because there's an imaginary 1 right there. Okay, so on our product side, now switching to a different color, on our on our product side, how many aluminum atoms do we have now? Yeah, we have 2. Yeah, that's not right, right? I'm already noticing that this isn't balanced. And then how many sulfurs do we have? Yeah, we have 3. Okay, 3 sulfur atoms. So this is not balanced. Okay, so what can we do? Well, and let's actually write it over here. I would rather write it down in a little slightly different way for you, so I can show you how I actually solve these. So we have aluminum in the solid form plus S in the solid form, sulfur, and that gives us, you'll often hear me say gives when I put the arrow down, gives, that's a common thing to say, aluminum 2S3, and that's a solid form. Okay, so we have now, the way that I like to do it is I leave these little spaces here, but I put a little spacer in front, okay? And you'll know why that is in a second. Then what I do is I actually kind of like draw a line in between my, right under my arrow, to show, hey, this is what I have before and this is what I have after. So we already did this, but we're going to count the number of each atom. So I'm going to put each atom that I have, I'm going to list it. So I have aluminum and I have sulfur atoms. Over here, I should have the same thing, right? I started with aluminum atoms and sulfur atoms, so I should have aluminum atoms and sulfur atoms on the right. Okay, now I'm just going to draw a little dash just because I'm going to be putting the number of atoms that I have there. So right now, our coefficients, which are these blanks right here, actually let me highlight. We have these numbers in front, and right now you don't see anything, and I'll tell you why, called coefficients. And those coefficients tell us how many of that chemical compound or that chemical or that substance that we have. Okay? So if I have a 1 right here, it's telling me that I have 1 of this compound here. I have 1 aluminum sulfide. And you'll learn how to name those later. Did I mention that already? I can't remember. So I have 1 aluminum sulfide. If I change this to 2, just looking at the right-hand side right now, if I make that a 2, how many of this compound do I have? Yeah, I have 2. So really what this is saying is, when you're changing that coefficient, that number in front, it's saying that you're adding more or taking away some of your compound. Another aluminum sulfide compound. And now I have 3 of those compounds. Okay? Notice that I'm never changing these numbers. And the reason that I'm not changing those numbers is because we cannot change the identity of the substance that we're making. If I change this to 1, I no longer have aluminum sulfide. I have a different type of compound. Kind of a weird example here with aluminum sulfide, but with like something more accessible like CO2, something we know of better, I should say. If I change this 2 on the oxygen to 1, if I had started with 1 oxygen and I wanted to end with 1 oxygen, for example, and I was like, oh, let me just get rid of that and we'll make that a 1. Well, if that's a 1, is CO2 the same thing as CO? No, they're completely different compounds. CO2, carbon dioxide, is something we breathe in every day, all day. Carbon monoxide is not something we should be breathing in, okay? So we're not allowed, it's illegal to change these subscripts, okay? But what you can change is how many of those compounds you have. And the way you do that is by changing the number in front of that compound. Okay, hopefully that makes sense. I know this is kind of, it's hard at first, but with lots and lots of practice, you'll get better. Okay, and we're going to do a lot of practice. Okay, so what I like to do when I start off with these problems to balance them is I like to put my coefficient as 1 in front. And the reason I do that is because I know if I'm doing this chemical reaction, I must have at least 1 of each of my substances, okay? Because the reaction is happening. So let's just go with the lowest ratio at first and say I have 1 of each, okay? So when I have a 1 in front as my coefficient, now I can start to count how many actual individual atoms I have. So if there's a 1 in front of that aluminum, what we do is we actually multiply this 1, whatever coefficient we have, by the number here. And remember, there's an imaginary 1, so right now I will show it. Okay, so you multiply the coefficient by the number that's right here for each of your elements. Okay, so what do I mean by that? Okay, so let's try it. So 1 is in front of this aluminum here, and I'm multiplying it by that imaginary 1. So how many aluminums do I have? Aluminum atoms? Yeah, I just have 1. Okay, because 1 times 1 times 1 is 1. All right, how about with sulfur? Remember, I'm multiplying that coefficient by the number here, and that's going to tell me how many sulfur atoms I have. Yeah, I just have 1, right? So 1. Okay, now it's a little bit trickier. Let's go to the right side. When I multiply this 1 by the aluminum, by the subscript on the aluminum, what do I have now? How many aluminum atoms do I have on the right there? Yeah, 1 times 2 is 2. So I actually have 2 aluminum atoms right here. Okay, and that makes sense because if I look at my compound, there are 2 aluminums here, and I only have 1 of that compound. So how many aluminums do I have? Yeah, I have 2. All right, and how many sulfurs do I have? Now this one also gets multiplied here, so it gets multiplied to here and here. Okay, because I have 1 of everything within this little circle here, that whole compound. Yeah, I have 3 sulfurs, okay, because that 1 gets multiplied by that 3 to show that we have 3 sulfur atoms. Okay, so that's just like what we got over here, right? We said, nope, there's only 1 aluminum atom and 1 sulfur atom, and 2 aluminum atoms and 3 on the right. Okay, so how are we going to balance this? Well, we're not allowed to change these, right? And I want to have the same numbers here for each atom as I have here for each atom. Okay? So ideally, I would like this to be 3 and this to be 2. But we have to actually change our equation. We can't just change the numbers down there. Okay, so how are we going to change this equation? Well, the only thing I'm allowed to change are the coefficients, these things in red here. So let's do that. So if I change a coefficient for let's start with aluminum. Let's say, okay, I want to get to 2 aluminums. Okay, so let me just go ahead and change this here, this 1 to 2. When I change that, now we got to make sure we update this part here because we no longer just have 1 aluminum atom, right? We now have how many? That coefficient gets multiplied by 1. So we have 2 times 1, which is 2. Okay, great. I'm looking at this and I'm seeing, okay, my aluminums, they match up now. What about my sulfurs? My sulfurs are still off. So what number am I going to change this 1 to in front of the sulfur? Yeah, I'm going to change it to 3. Yeah. Pause the video and think about that for a second if you need to. Okay, I'm changing it to 3. Why am I changing it to 3? Because there's a 1 here. Whatever I have over here gets multiplied by that subscript, and that's how many atoms I have. Okay. I hope that's starting to make sense. So now just do a final check. I started with 2 aluminums and I ended with 2 aluminums. Great. I started with 3 sulfurs and I ended with 3 sulfurs. Awesome. So this is the lowest ratio that these things can react in, that these 2 reactants react in, and they produce this amount of that compound. Okay? All right, let's, I think there's a couple more examples down here. Okay, so balance the chemical equation when solid Fe3O4 reacts with hydrogen gas to produce solid iron in water. All right, let's go ahead and I think let's write it over here so we have a little bit more room. So Fe3O4 in solid form plus H2 gas. You know what? I'm actually going to leave out the subscripts for now because I think they kind of complicate things. In the future, you'll get used to using them and we will do some work with them. But for now, I'm going to take them out because they're just complicating things a little bit. And we just are learning this for the first time. Okay, so plus H2O. And remember, I leave those little gaps so that I can fill in my coefficients because those are the things I'm actually allowed to change. Okay, so I have that chemical equation, and now I need to balance it. So first, let's check if we actually have it balanced, because that would be ideal. So remember, my first step is I draw that line down the middle between right under the arrow, between our reactants and our products. And then I put a 1 right here to say, okay, I have at least 1 of each of these things. All right, now I'm going to list the types of atoms that I start with. Okay, so I start with iron atoms. So let's list Fe is iron. I start with oxygen atoms. I'm not counting yet. I'm just writing what types of atoms I have, what elements. Why isn't it letting me draw? That's weird. hold on 1 second, you guys. See what's going on here. Is that gonna help? What is going on here? That is so weird. There we go. Huh. Okay, sorry. Thanks for sticking with me there. I have no idea what was going on. Okay, hopefully I can edit that to make it a little shorter. All right. Oh, and then, so I have oxygen atoms, and now I'm listing what other one that I have. I have hydrogen. So if I start with iron, oxygen, and hydrogen atoms, I better end with each of those types of atoms, right? Because we can't gain or lose those atoms. Okay. Now I've listed the types of atoms. Let's go ahead and count, assuming that I have one as my coefficient. So one of each of these species, we could call them as well. Sometimes you'll hear that. Okay. So for my Fe, for my iron, if my coefficient in front of that iron is 1, what number am I multiplying 1 by? What am I multiplying my coefficient by? Yeah, this number 3, okay? So I have 1 of this entire compound, and within that compound, there are 3 iron atoms. So I need to multiply 1 by that 3 there. So that gives me 3 iron atoms to start with. What about oxygen? Yeah, 4 oxygen atoms. I'm multiplying that 1 in front by the 4 over there. How many hydrogen? There's a little 2 by that hydrogen. So 1 times 2 is 2. Yeah, we got 2 hydrogen atoms. 1 H2 compound, but within that compound, there's 2 hydrogen atoms. So we have to account for those. All right, and remember, we're counting atoms. Okay, now on the right side, how many irons do I have? Just 1, right? There's an imaginary 1 right here. Okay. What about hydrogens on that right side? Yeah, 2. Okay, whoops. Got all thick for some reason. 2. And then how many oxygens? Yeah, 1. There's an imaginary 1 there. Okay. All right, so are we balanced? No, we're not balanced right now, right? We have 3 irons on the left and 1 on the right, 4 oxygens on the left and 1 on the right, 2 oxygens on the left and 2 hydrogens on the left and 2 hydrogens on the right. So hydrogen looks okay, but I don't know that we're going to get around. We have to change this number here because we don't have O's. Our oxygens are out of balance. Okay, so where do I start? I don't know. Where should we start? Well, what if we do just start with water? Let's just try that. What if we start with water? So if we start with water, let's make that, what can we do? What can we change? We can only change the number in front, the coefficient. So let's go ahead and say, instead of 1 water compound, water molecule, I'm going to say I have 2. And when I change that, I need to readjust my values, right? Because I just changed it. So how many oxygens do I have now? Yeah, 2, because there's an imaginary 1 there. And how many hydrogens? 2 times 2 is 4. So I have 4 hydrogens on that side now. Okay, well that didn't work because now I have neither of my oxygens or my hydrogens are correct. So let's go back to square 1 and let's pretend we have 1 there again. What could we do instead? Should we make it a 4? Okay, let's try that. Let's go ahead and make it a 4. I'm going to make this a 4. And that way my oxygens are going to be 4. My hydrogens now are going to be what? 4 times 2. Yeah, 8. Okay, well that's kind of weird. Well, but that's okay. So this is all good. And maybe I can just change this hydrogen. What could I put here that would make this hydrogen equal 8 on the left? Yeah, I could make that a 4 as well, right? 4 times 2 is 8. All right, so now we got to adjust our number. So now I have 8 there. All right, and I would recommend, notice I'm not actually erasing these numbers. I would recommend that you don't erase and you just do one line through it like that, because then you can see what you actually started with. And if you, sometimes these get pretty messy and you'll realize like, you know what, I'm just gonna go back to square one, and then you can like, or even just back one step. And then you can actually just go back to the previous number you had listed there. So that's what I would recommend. Okay, so now we're looking at my iron, and I'm thinking, gosh, well, I don't know. My iron's kind of out of whack. Do I want to change this number here? No, if I change that number, I'm going to throw my oxygens off. It's also not going to help because I don't want more irons, right? I want to get this to 3. Okay, so, and sometimes you will have to do that, but all right, so what if we make this a 3? Is that allowed? Yeah, that's allowed. You can have odd numbers. Okay. All right, now I'm looking at this. And what is this chemical equation actually saying? So it's saying that one FeO4, or Fe3O4, sorry, is reacting with 4 H2s, and giving us 3 Fe's and 4 H2Os. Yeah. And we know it's balanced because I'm looking, as long as I did my math right, these are all the same. I put in 3 irons and I got out 3 irons. I put in 4 oxygens and I got out 4 oxygens. I put in 8 hydrogens and I got out 8 hydrogens. Okay, so let's check our work here. That would suck if I got it wrong, wouldn't it? That was a lot of work. Okay, so 3, 4... Did I get it wrong? Wait, 3, 4, and 2. Oh no, that was their first step. I was like, what are they talking about? Okay. I was looking at, they're still not balanced in this step. Okay. So in the final step, yes, we got it right. Great. Oh my gosh. Okay. All right, let's see. I'm not going to walk you through these next 2 learning checks. I want you to try them out on your own, and then we'll talk about the solution in class, okay? So sound good? So try these out on your own, and then we'll do them together in class. All right, I'll see you in class, and have a good rest of your day.